I'm using Sklearn's LeavePGroupsOut for cross-validation. It's a special type of cross-validation that's aware of groups in my data. That is super important when data samples are clustered. I have 15 data points, and I've divided them into 3 distinct groups. This grouping is crucial for how the cross-validation will work. I'm using the LeavePGroupsOut function, telling it to leave out 2 groups at a time during testing. Is the key here, telling the function how many groups I want in my testing set for each split. This shows exactly how my 15 samples are assigned to groups 0, 1, and 2. Notice that group 0 has 3 samples, group 1 has 5, and group 2 has 7 samples. This is a fundamental input to the cross-validation process. Because I have 3 groups and I'm leaving out 2 at a time, I get 3 different ways to split my data: 0, 1, 0, 2, and 1, 2. Think of it like this: you're selecting testing groups, and the rest become training groups. These are the indices, positions, of the data points that will be part of my training set for a given split. These are the indices, positions, of the data points that make up my testing set. This refers to the number of data points in the training and testing sets for a particular split. It basically gives me the dimensions of each set. For the first split, I have 7 samples in my training set and 8 in my testing set. This is because for the first split groups 0 and 1 are left out. I'm using the LeavePGroupsOut function from Sklearn, a powerful tool for cross-validation. It's specifically designed to handle situations where you have groups of related samples, like in your problem. It makes sure that samples within the same group aren't split between training and testing sets. We're working with a dataset containing 15 samples. These samples are further categorized into 3 distinct groups. The LeavePGroupsOut algorithm is the heart of this problem. I'll use it to divide my dataset into training and testing sets while making sure samples from the same group always stay together. That is, either all samples in a group are part of the training set or all are part of the testing set. I need to determine how many different ways I can split my data into training and testing sets using LeavePGroupsOut. Given that I'm leaving out 2 groups at a time, and there are 3 groups, I calculate 3 possible combinations of groups to leave out for testing. Each combination represents a different split. These indices tell me which samples will be used to train my model in each split. It varies across each split. These indices pinpoint the samples reserved for testing the model's performance in each split. It's different for each split. This option suggests 3 splits, with 11 samples in the training set and 4 in the testing set for each. However, this is incorrect, given that the number of samples in training and testing sets changes with each split in this specific case. Another option proposes 3 splits, with 9 samples for training and 6 for testing. While the number of splits is correct, the sizes of the training and testing sets are not consistently true. For every split, this option wrongly predicts 6 splits. The test sizes are partially correct only if you change the input parameter from _n_ groups equals 2 to _n_ groups equals 1 . But the question specified _n_ groups equals 2 . Similar to option C, this option is wrong in the number of splits, but also in the test split size even with changed parameters. The number of splits is not 6. I have a dataset with 15 samples, neatly divided into 3 groups. This is important because my cross-validation method will consider these groups. I'm using Sklearn's LeavePGroupsOut function. The _n_ groups equals 2 part tells LeavePGroupsOut to leave out 2 groups during each test. This means in each split, 2 entire groups go to the test set and the rest go to the training set. I need to figure out how many different ways I can split my data following the rules of LeavePGroupsOut with _n_ groups equals 2 . Because I have 3 groups, and LeavePGroupsOut leaves out 2 groups at a time, there are only 3 combinations of 2 groups that can be excluded. Groups 0, 1, 0, 2, and 1, 2. That gives me 3 splits. For the first split, I want to know precisely which samples go into the training set and which go into the test set. This shows the indices, positions, of the samples that form the training set for split 1. This shows the indices, positions, of the samples that form the test set for split 1. This option suggests 3 splits, a training set of 11 samples, and a test set of 4 samples. This option suggests 3 splits, a training set of 9 samples, and a test set of 6 samples. This option suggests 6 splits, a training set of 9 samples, and a test set of 6 samples. This option suggests 6 splits, a training set of 11 samples, and a test set of 4 samples. This list shows which group each of the 15 samples belongs to. For example, samples 0, 1, and 2 are in group 0, samples 3, 4, 5, 6, and 7 are in group 1, and samples 8 through 14 are in group 2. I'm using LeavePGroupsOut from Sklearn, a powerful tool for doing cross-validation. This method is super cool because it makes sure that when I'm splitting my data, samples from the same group don't end up in both the training and testing sets at the same time. That's crucial to avoid data leakage and get unbiased results. I have a dataset with 15 samples. These samples are divided into 3 different groups. This grouping is important because it influences how I split the data in cross-validation. It's like sorting candies into different bowls. This list shows which group each sample belongs to. For example, the first 3 samples belong to group 0, the next 5 to group 1, and the last 7 to group 2. I'll use this information to guide my cross-validation process to ensure I only compare apples to apples, same group. I'm using the LeavePGroupsOut function and telling it to leave out 2 groups at a time during testing. The _n_groups equals 2 parameter is the key here, deciding how many groups get left aside. I'm about to generate different splits of my data using LeavePGroupsOut. Each split will have a training set and a testing set, carefully constructed to respect group membership. Because I have 3 groups and I'm leaving out 2 at a time, I will have exactly 3 different ways to split my data into training and testing sets. Think of it as selecting 2 groups out of 3. There are only 3 combinations. This option suggests 11 samples in the training set and 4 in the testing set for the first split. I'll check if this matches what LeavePGroupsOut actually produces. Option B proposes a training set of 9 samples and a testing set of 6. Again, I'll need to verify this with the actual results. Similar to B, this suggests a 9/6 split. Let's see if it's correct. Option D also suggests an 11/4 split. I'll compare this against the actual output of the LeavePGroupsOut function. I'm working with a dataset containing 15 samples that are divided into 3 groups. This is important because the cross-validation technique I'll use considers these groups. I'll use Sklearn's LeavePGroupsOut function, which performs cross-validation while keeping samples from the same group together. The _n_groups equals 2 part means I'll leave out 2 entire groups when creating my test sets for each split. Because I have 3 groups and I am leaving out 2 at a time, I'll create multiple different training and testing sets. I need to figure out exactly how many. This option suggests 3 splits, with 1 split having 11 samples for training and 4 for testing. Let's see if this matches my calculations. This option also proposes 3 splits, but with 9 training samples and 6 testing samples in one of the splits. This is another possibility to consider. Here, we have 6 splits, and one of them has 9 training and 6 testing samples. Interesting. The final option suggests 6 splits, with 1 split showing 11 training and 4 testing samples. Let's check which is correct. I want to figure out exactly what samples end up in my training and testing sets for the very first split created by LeavePGroupsOut. This will help me narrow down which multiple choice option is right. I'm using LeavePGroupsOut, a scikit-learn function, to do cross-validation. This is a special type of cross-validation that's super helpful when you have groups of similar data points. It makes sure that data points from the same group aren't accidentally split between training and testing sets. That would ruin the test and the results. I have 15 data points in my dataset, and these are naturally divided into 3 groups. This grouping is important because LeavePGroupsOut works by considering these groups. This shows how the 15 data points are grouped. The first 3 points belong to group 0, the next 5 to group 1, and the last 7 to group 2. This is what guides the cross-validation process. I'm telling LeavePGroupsOut to leave out 2 groups during testing in each split. ngroups is the parameter setting the number of groups to exclude for testing. I will get a certain number of distinct training and testing data splits. This depends on how many groups there are and how many I am leaving out for testing. Because I have 3 groups, and I'm leaving out 2 groups per split, I'll get exactly 3 splits. This is because 3 is the number of combinations of choosing 2 groups out of 3. Let's look at the very first training and testing split generated. This shows which data points are used in the training set for this first split. This shows which data points are used in the testing set for this first split. The exact number of training and testing points will change each time because different groups are left out for testing in each iteration of the cross-validation.